The question says a glass tube sealed at both the ends is 100 centimeter long. It lies horizontally with the middle 10 centimeter containing mercury. Now let us first of all draw the diagram. What is it is saying that this is basically a glass tube. It is somewhat like this probably, yeah, and it contains mercury at the center 10 centimeter, right? This is all mercury. Now the entire length is 100 centimeter. And in the middle it is 10 centimeter, right? Now it is in the middle, that means this must be 45, right? 45 centimeter, and this should also be 45 centimeter. Now right now it is, the entire tube is at 27 degrees Celsius. This is 27 degrees Celsius and this is also 27 degrees Celsius. Now afterward what happens is that, you know, this tube, now this mercury shifts somewhere. It can shift either right or left. Let us assume that it has shifted right, left, and towards the distance x. So that means this distance, what will be this? This would be 45 minus x, right? Because earlier it was 45. Now the mercury has shifted x towards the right. So basically now this entire length would be what? 45 plus x, right? Now let us assume that this is compartment 1, this is compartment, this is also compartment 1. Now this is 2 and this is 2, right? Right, so basically this is 0 degrees Celsius compartment and this now becomes 127 degrees Celsius, am I right? Because it is shown that two ends of the tube contain air at 27 degrees Celsius and a pressure of 76 centimeter of mercury. The air column on one side is maintained at 0 degrees Celsius. This is basically the 0 degrees Celsius. And the other side is maintained at 127 degrees Celsius. This side is 127 degrees Celsius. Calculate the length of the air column on the cooler side. So basically on the cooler side we have to calculate the length of the air column in the compartment 1. Neglect the changes in the volume of the mercury and that of the glass, right? So basically there must be some air which is contained in this column and in second part as well. Now when we have reduced the temperature, what happens is the volume also reduces, right? But the number of moles of the gas contained in container 1 will be equal to the number of moles in container 1 earlier and afterwards, because no gas leak is taking place. So now basically what we have to do is like number of moles in container 1. What will happen to the number of moles in container 1? Earlier number of moles was P into V. Let us suppose the pressure was P naught into V. What was the volume? 45 into area of the tube. This is the volume divided by the temperature. Temperature was 300 Kelvin into R, right? This should be equal to latter, basically the number of moles afterwards when it is 0 degrees Celsius. Let us assume that the pressure is P1 and what is the volume? 45 minus X into A divided by of 273 into R, right? So basically we can equate both these things because the number of moles will be same, right? Now this is equation 1. Now if I talk about the number of moles in 2, and basically compartment 2, so what I can write? I can write that P naught into 45 into A, same as that in 1, right? Because 300 into A into R, because the pressure was same in both the compartments earlier and the volume was also same and the temperature was also same. But now what has happened is, let us assume this is P2. Pressure in, you know, the second compartment is P2. What will be the volume? 45 plus X into A divided by of 400 R, right? So I can cancel these two things, right? Now we also know that because, you know, mercury is over here, it is basically shifted to somewhere at an equilibrium position. If this is equilibrium, that means pressure in this compartment should be equal to the pressure in this compartment. That means P1 should be equal to P2. Is that right? So basically what we can do is we can divide the first equation with the second equation and use the third equation in that, right? If we divide these two equations, what will I get? I will get 1 will be equal to basically P1 by P2 into 45 minus x divided by 45 plus x into 400 by 270, right? So now since P1 is equals to P2, so I can cut these two things. Now from this equation we can calculate the value of x. Now from this equation, if you calculate the value of x, x would come out to be approximately 8.49, right? Now it is asking the length of the air column on the cooler side. So basically we have to calculate what? 45 minus x, which will come out to be 36.51 centimeters. So this is the answer, right? So basically, the question was not tough again, as we have seen in earlier questions. Question was not tough, but the problem was going in a systematic manner and you should not be afraid after seeing the question, how will I solve it? Just go step by step in a proper manner and you will be able to solve it.